curve will be, so you guys have copied down the equations right here, right? Have you? So I'm counting on you guys. Okay. So the level curve is very similar to the traces. Okay. Next one I want to do is level curves. So we have a function defined by f of x, y. Okay, so this f of xy can be given by different formulas. You can have linear formula, which will give a plane. You can have a quadratic formula, will give you quadratic surfaces. Okay, but in any case, this is the general expression of a two-variable function. Okay, two-variable function, and we have the z equals 0. If I make z equals 0 in this equation, I'm getting fxy is equal to 0. Alright? I'm getting fxy equals 0. And this is not very foreign to us. Remember, what did we do? What did we try to find when we make a z equals 0? The xy trace. Right? So this is actually defining an xy trace, which in most of the cases is a curve on the xy plane. But this z equals 0, 0 as a value is a pretty peculiar choice. You can choose any value you want. Alright? We can choose z equals 1. I'm trying to ask the question, what does f of xy equals 1 mean? I can make z equals 2. I can ask the question, what does f of xy equals 2 mean? Do you still remember the question we did? Right? So z equals 0, z equals 1, we have f xy is equal to 1. Fxy equals 1 will still define a curve. Where is this curve and what does it mean? Right? Fxy equals 1, according to the different formula, this is going to be a curve. Where is this curve and what does it mean? That's the question we asked in Monday's class. You still remember the answer we had? Yeah. So z equals 1 defines a plane, not an xy plane anymore, but it is parallel to xy plane. You can lift it a bit to level 1, and this level as a plane will still intersect with the surface. Right? A plane intersecting with the surface is still a curve. So this equation actually defines a curve as the intersection between the surface and a level plane at 1. Are with me? It's not exactly a trace anymore, but it is still an intersection. So this is the intersecting curve. Between the level point z equals 1 and the surface. The surface as the graph of the function z equals fxy. Okay? Surface of z equals fxy. I can also choose all arbitrary values for z. I can choose z to be any arbitrary real value, and then this will be the level curves. Okay? And next, let's look at a couple of examples. Let's begin from this one. Easy to demonstrate level curves. So I already have the picture over there. So I want to first compute the level curve when z is equal to 1. Okay. So I want to compute the level curve when z is equal to 1. What is it? So it's nothing but square root of 1 plus x squared plus y squared is equal to 1. Alright? So we can simplify this equation to get 1 plus x squared plus y squared is equal to 1. So x squared plus y squared is equal to 0. And we have played this game a lot. Sum of two squares equal to 0. The only possibility is both of them are equal to 0. So the level curve, even though I'm giving the name of level curve, in this case, this curve will be pretty degenerate. It's gonna be not a curve, but only a point. Okay. So if I want to draw the intersection between my level plane and 1 and the surface, this one will be the only intersection we have. But if I want to draw this intersection back onto the xy plane, because this one has nothing to do with z anymore. This is just an equation involving xy, so I can indeed draw the curve or a point on the xy plane. That was me? So even though it is intersection between a level plane and a surface, but I can indeed draw this curve, a degenerate curve, back onto the xy plane. So on xy plane, this is the level curve at z equals 0. Yes, this is the level curve at z equals 0. I can choose z equals, say, that's 2. So if z is equal to 2, the equation we're getting is square root of 1 plus x squared plus y squared is equal to 2. So we can simplify this to get x squared plus y squared is equal to 3. All right? You have to square both sides and move terms around. So this is the equation at level 2. So in the surface, we're looking at the intersection between a different level plane with a level, so this is z equals 1, this is z equals 2. So the intersection between these two will be a circle curve, all right? So the intersection between a level plane at 2 with the surface will be the level, will be a circle curve over here, and that circle is indeed centered at 0, 0 with radius of square root of 3. I can still look at the intersection on that picture, but when I draw this equation, it is still on the xy plane. So I can draw this plane on xy, I can draw this circle on xy plane centered at 0 with radius of square root of 2. Actually, square root of 3. So this is the level curve when z is equal to 1. This is the level curve z is equal to 2. Yeah, we're pretty much done. So there are two different understandings of what is level curve. One understanding is just by choosing different z values, you're getting different equations involving x and y. Right? One particular value will give you an equation, and that equation on the xy plane will define a circle, and in some cases degenerate a circle right here. On the other hand, if you're looking at from the intersection point of view, I'm choosing different level planes and intersect with the surface I'm getting in the very beginning, and then I project this curve back onto the xy plane. That is exactly the level curve I'm getting. Now we see. So there are two different understandings you can get from a level curve. One understanding is you just look at the equation by choosing the value of z, and you're getting an equation involving only x and y, and that will define a curve on the xy plane. The other understanding is probably more geometric. You choose these different levels of planes, and then you intersect with the surface. And every intersection is a curve. And in this case, they are circles, or degenerate circles. And then you project these curves back onto the xy plane. That will be exactly this level curve system. Okay? So level curves are still on xy plane after you project them. Okay? So I want to make the, so these level curves are still on xy plane. So when you draw your level curve, okay, when you draw your level curve, you don't have to draw the surface. Now with me? You don't have to draw your surface. You can draw the level, you can draw your surface and draw all these level planes to intersect and find out where the curve is and project on the xy plane. However, that is in some cases more complicated. You only need to look at the formula and choose different values and only draw the curve on xy plane without even worrying about the three-dimensional case. Now with me? You don't have to draw the surface all the time. You only need to do this for two-dimensional plane. Okay, I will give you an example. I want to do one more level curve for this example that we're done. So when z equals 3, square root of 1 plus x squared plus y squared is equal to 3. So I'm getting x squared plus y squared is equal to 8. So this is a larger circle with the same center but greater radius. So this is square root of 8 as my radius, and this is the level curve when z is equal to 3. So when you increase your levels, when you make the level higher and higher, this intersection as the intersection of the level plane with the surface will get larger and larger. Okay? But you can always project onto the xy plane and see what they are. That's the first point. Second point I want to make is ask you this equation. I said we can choose freely the value of z. I'm choosing the values from 1, 2, 3, and so on. How about choose the value, for instance, z equals 0 for example? You get a square root of 1 plus x squared plus y squared is equal to 0, and this can never happen. Right? This can never happen because you can square both sides, you're getting x squared plus y squared is equal to minus 1. That can never happen in the real plane. Alright? So one interpretation you can get is there's no level curve corresponding to this value because this value is not in the range. Right? You can only get level curves if your value is within the range. Alright? The range, by definition, is all the possible values for z to take. If you're taking a value which is out of the range, that means there's no corresponding x and y values to take this z value. So only when your z value is within the range, you can get a level curve. On the other hand, you can still go back to your picture right here. If I'm trying to find a level curve at a level equals 0, I have to find a level curve at z equals 0, which is the xy plane, and intersect with the surface. Only in this case, there's no intersection at all. Alright? There's no intersection at all. In other words, there's no level curve. There's no level curve. So this will be the general theme of all the multi-level calculus. We can understand from the geometry. We have the picture. But in most of the cases, the picture is not easy to draw. Even without a picture, you should still be able to convince yourself all the calculus, why they're true and how to compute them. In this case, I don't even need to look at the picture. I know z is out of the range. There has to be no level curve at all. Okay? So I'm giving you one more example, so maybe two more examples to give you a general theme of what I was talking about. So this particular example, we know how to draw the surface. In some other examples, we don't know how to draw the surface, but we can still graph the level curves. So the first example I have is z is equal to 4 cosine 5x plus 1. Okay. I don't see any linear term, I don't see squares, so this is not a plane nor a quadratic surface. It's a trigonometric function. Okay? If you're trying to graph the function, it's not going to be easy. You can look at the book and see what the pictures are. Because you have trigonometric functions, this surface has to be in some sense periodic. It has to be in some sense periodic. But drawing the picture is not going to be as straightforward as we saw before. But I can still draw the level curves. And I can still draw the level curves. I can make z is equal to, for instance, 4, I can z equals 2, z equals 0, and z equals minus 2, and z equals minus 4. I will be able to draw the level curves according to these values. And before I'm saying cosine 5x plus y is equal to 1, right? So this is equal to 1, even though cosine value is periodic, but I can at least choose one of them, which is 5x plus y is equal to 0, right? It is equal to 1, it is equal to 0, or 2 pi, or any 2 k pi's, right? But we can choose one of them before this curve first. So 5x plus y is equal to 0. This is a line. I said this in a lot of cases. Linear function, 2 variables have to be a line, right? And this is actually a line passing through the origin with slope -1